for you. Who said that? Monique. Monique is always fantastic. Okay, so now we try to connect it again. Suppose que we have again one parabola. And suppose que we have another parabola, but a cubic parabola. It's a cubic and this is a square. You know that because the end behavior is different. No? Okay, this is x-axis. This is y-axis. This is the most important idea now. This is history. I recall because I need to. But now you apply the horizontal. Horizontal is the horizontal line. Horizontal line. See if this crosses in 2 points, it's not one-to-one. See crossing only 1 point, yes, it's one-to-one. This is the perfect way to prove. So you have the function that's given in the problem. You apply, you are doing the graph. This is super easy because you put in decimals maybe. Now you apply the horizontal line test. See, pass the test, it's one-to-one. Therefore, we can find the inverse according to the way I want to explain in a few minutes. Okay. However, sometimes happen is suppose you maybe one question can fly in the air, professor. But you explain at the beginning a square function and the square root function are inverse function, no? Yes. Entonces, pero what the reason que you explain me now que square function is no one-to-one, entonces a square function no have no inverse. Yeah, because this is a contradiction, yes, of course, but I can fix it. How you can fix it? Because, for example, this is complicated to explain, but I try to do my best. Look, the problem is that the definition of the function is not only the equation f of x equal x squared. No. This is the incomplete definition. We need 3 pieces. You need the formula, the equation, yes, but you need domain and you need range. Okay, in this case, the domain of this, the quadratic function original without do anything is already a number, it's obvious. However, the range, no, the range is the positive number because any positive or negative number square is positive. You see that the parabola open up. Entonces, bracket 0, infinity. Okay, this is the definition of that one. However, I want to change a little bit this definition for the one same expression. This doesn't change, stay the same. However, I want to change domain and range. Well, range, no, range stays the same. However, domain, I suppose it's only the positive or the negative. But I suppose it's more elegant, in my opinion, the positive side. Bracket 0, infinity. Actually, the graph of this now is the half of parabola. Of course, the positive part of the parabola. Same expression, but I make a restriction in the domain. So when you apply the famous horizontal line test, you pass the test. So this function, yes, is one-to-one. And this function no one-to-one. Therefore, this function one-to-one, yes, have inverse, and this no inverse. No inverse. Everyone follow me? Sure? It's easy or no? Okay, so let's move on directly to the example. I bring 3 examples. Illustrate, in my opinion, very, very well this idea. Okay. May I erase the board or no? Guys, you are with me or no?
Yeah.
Okay, cool. Okay, let me see the name. Alberto, Isabella, Daniel, Nia, Nathan, Angelina, Walter, Anthony, Steve, Jamie. I think I don't know the name. It's a guest user. Patrick, Leslie, Yailin, Anne, Anahi Torres, Julio Rodriguez, y Monique. Monique always help me to remind me the recording. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 students. I'm the enrollment, the enrollment, the roster have 32 students. I suppose that only you pass this class. Okay. Okay, no problem. This is not our problem. Let me try to see example to understand much better this idea, que a little bit theoretical, no? No. One definition, one theorema, and 3 problems at least. 3 examples at least. Example 1. Example 1. Example 1 is a function. It's given the expression que es x cubed plus 3. Okay, cool. So what should I do? Well, we should I do a lot of things. It's 5 steps. Number 1 step is determine. We apply in any example this step. Determine si es 1-to-1 or not. Number 2, que is the most important step, is find the inverse function. Wow. Number 3, you verify if this inverse is correct or no. How you verify it? There are many ways to do. However, the most popular is find the composition F inverse, so put together in either order. For example, F inverse F of x. Okay, by the way, guys, we can use in that notation. However, we can use in this notation because you are familiar. F composition F inverse. This 0 indicate composition. That's exactly the same as this. And F inverse composition F. And surprisingly, the answer of both is X, que es called identity function. Identity function. It's a function weird because y equals x. So si x is 1, y is 1. Si x is 2, y is 2. It's a line. It's a line can be set the first quadrant and the third quadrant. That's identity function. And it's a logical. Suppose one elementary example. Now this is a little bit complicated. Suppose that I select addition and subtraction. Suppose the function x plus 10. I select arbitrary number. Entonces the subtraction is x minus 10. No? A subtraction. And you pick one value. Suppose you pick x equals 5. Logging in here, 15. 5 plus 10, 15. And you plug in this 15 and the subtraction, que I suppose hypothetically, no? Que es the inverse function, and 15 minus 10 is 5. Wow. And we come back at the beginning. That is a reason that when you put the function and its inverse each other, on those each other, and the answer is identity function. Make sense? It's clear or no? No? Confusing? Number 4 is compute domain and range. But the domain and range of who? Of the original F or the inverse? Both. Because it's easy. Look. Domain of F, range of F, domain of F inverse, and range of F inverse. Remember the idea behind the inverse is you interchange x and y. So this x represent the domain of the original f, no? And this is the range of the original f. However, when you are doing in opposite direction, this is the domain of the inverser, and this is the range of the inverser. Conclusion: domain of the original is equal to the range of the inverser. And this is equal to this, and this is equal to that. This idea is clear, right? And finally, why not? Guys, I promise you this is super useful in this chapter, because we study after that two new functions, exponential and logarithmic. And by the way, these functions are inverse of each other. Therefore, it's important to understand very well, no? The logarithmic and exponential, the inverse function. And number 5 is do the graph. Do the graph of what? Of both functions, of the inverse function, of the given, que is no inverse. But it's super easy, because you plot, for example, suppose you plot 1 point, 2,4, and the original f. What would be the point in the inverse? Oh, 4,2, because you interchange x and y. This is the key idea, guys. Interchange x and y. Okay, no more theoretical part. Let's doing again my problem. I don't want to erase this, because this is the guideline to solving that problems. Okay, cool. My first problem. What do you think about f of x equal x cubed plus 3 is 1-to-1 or no? What do you think? Yes or no? Yes or no? It's my problem right now. Discover yes, somehow. Yes. Come on. Opinion. Opinion.
It's 1-to-1.
It's 1-to-1. Okay. I agree with you, but I need reason. Why? What thing you apply to understand it's 1-to-1?
Because it's a cubic function, so with the horizontal line test, it would only contact that 1 point.
Super cool. This is the answer. Okay, you need to remember the given function is a cubic function. On a cubic function, you know, can look like that, the graphic. It's a cubic. However, cubic function plus 3, it's similar. It's similar because it's just vertical shift 3 units up. So say 1, 2, 3, this point 1, 2, 3, I suppose hypothetical is this. This is a cubic plus 3, no? Do you understand the difference between the red and blue? And when you apply the famous very horizontal, line test in the blue, let me erase the red. The red only I use it to auxiliary to understand the blue. You apply closing only 1 point. And the answer is yes. Yes, it is a 1-to-1. Everyone follow me so far? Everyone follow me so far?
Yeah.
Okay. Now number 2 is the most important moment. What is the procedure? Moni dice, zoom up. Okay, entonces now number 2 is the most important, guys. Pay attention. Is you have the function is given at the beginning in my problem. Okay, I need to find the inverse. This is my goal. Find the inverse. Okay, so remember, always it's the same. You replace f of x for y. You know that this is perfect legal, because when you study function notation, you declare que y is equal f of x. However, what is the reason that we use sometimes function notation? Maybe because you see much better transformation or another application. But it's equivalent 100%. So you replace f of x for y, and now crucial moment, replace x for y. Interchange. This is most important. I put in the box because it's the most important. Now x is equal y cubic plus 3. Everyone follow me? And that's it. No. Why no? Actually, this is inverse. But what's the problem? Okay, this is expressed and implicit. Implicit no good, no clear. Implicit for. To express it and explicit is clear. Okay, the answer is the thing I want. You solve for y. But it's easy. In this example, you're subtracting 3. You apply cubic root both sides. Therefore, cubic root x minus 3 is equal to y, and this is the new y. And this new y is actually the inverse function. Wow, I like that. Okay, the inverse function is the cubic root x minus 3. Here I enclose in the box because this is important answer. So this is the original. In one direction, and this is the inverse is in opposite direction. Make sense or no? Using intuition. I suppose que yes, because the original, the operation is giving or is doing is raised to the cubic power according to the order of operation. No. When you plug in one number, the first operation you should do in the original is raised to the cubic power as addition 3. Entonces en the inverse function, we are doing completely power. You subtracting 3 and compute the cubic root. But I need to confirmation that this is okay or no. Guys, do you understand very well how I compute the inverse function?
Yes.
Okay, now step 3 is verify. Verify. How you verify? Well, you are doing composition. In this order, I'm doing by curiosity in both directions, but not necessarily doing in both directions. If one direction is okay, another I'm sure it's okay also, but I want to practice a little bit. So I am doing this. So let me try to understand. Remember the composition, we have two functions. This is the innermost, and this is the outer. And important, the order is extremely important. O sea, the F inverse is the innermost. O sea, the innermost is this. So you plugging in this circle red I put here into the F. Okay, in other word, you replace. Let me try to erase that part. You replace. So you copy the F, que es the outermost function, but you copy the box. Plus 3. This plus 3 obviously is this plus and this 3. And inside the box you put no x anymore. You put the cubic root of x minus 3. Cubic. Don't forget that power. And you know very well that cubic power and cubic root cancel out each other. And we have x minus 3 plus 3. Wow! And 3 positive and 3 negative cancel, and you get the identity function. This is verification que our inverse que we compute in the step 2 is good. Let me try to do here. Okay, Sandra. Okay. I have a good student in this class. I suppose that you are doing well, guys. Suppose now I want to do in opposite direction. Look. Opposite direction, let me use in blue color. Okay, in this case, the outermost function is f inverse, is this one. Then you copy, you copy, you copy, you copy, you copy. So you copy who? You copy this now, and you plug it in, plug it in, plug it in here, here, in the x place. You replace. So you have big, 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 big cubic root, and you put a box, and you put -3. Inside the box, you copy, completed the original function, cubic root 3. Actually, we have cubic root of x cubic plus 3 minus 3. Oh, again, it happened. We cancel out the 3 and -3, and we have cubic root f cubed, x obvious is x. Again, identical. Beautiful. Any question? No problema. And you have 2 more steps. Number 4 and number 5. But it's easy. Look at that. Let me show you. Number 4 is about domain and range. Let me copy again the original. Let me copy one more time the inverse function. And I want to find domain of f, range of f, domain of f inverse, and range of f inverse. What do you think about domain of the region? That one. Remember, in another chapter, when you study in detail the function theoretical part, we assume that the domain is all real number except restrictions. And we have restriction only when you have division by 0, so denominator, square root, not cubic root, square root. And well, square root on the top and the bottom. We have more restrictions we study in this chapter, but so far the only restriction that you know is this. So in this case, so we know. We have no, so the domain is all real number. Make sense? It's present and interval notation is from negative infinity to positive infinity. And this is exactly equal the range of the inverse. Now, always is complicated the domain. It's easier. Find the range, domain. Domain is easier than range. Range is complicated. So we dedicate to find domain of f inverse, and I know that this is equal to this. Well, in this case, we have the cubic root. You need to know, guys, when you see the library of the function in Cole algebra in the first part, the other chapter, we study the cubic root function. The graph look like that. This is the cubic root of the base, you know. However, the square root is different. The square root is like that. This is a square root. Why? The square root have only one branch, and the cubic root have 2 branches. The reason is obvious, because in the negative value is imaginary, and imaginary do not belong to the real number. Therefore, we have nothing in the negative part. However, here, yes. Why? Let me try to explain. For example, you compute the cubic root, negative 27. So it's obvious, square root negative 27, not real, imaginary, I. However, cubic root negative 27, yes, is -3, because -3 times -3 times -3 is -27. It's exactly the number that we have inside the cubic root. Okay, when there's negative, we have 3 negative, and multiplication 3 negative give me negative. So what is the idea behind cubic root? You need to find one number to multiply each other 3 times, give me exactly the number inside the radical symbol, que es negative 27. Wow, fantastic. Entonces now, the cubic root have positive value and negative value inside the domain. Therefore, again, it happens as order. And this domain of the inverse is equal to the range of the direct given function. Not always happen that there are perfect coincidence in between this. You see another example that no. But of course, in between this and this, yes. This is a fact. This is a theorem. So the theorem says domain of F is equal range of inverse. Always. And domain of inverse is equal range of the original function. This is a fact. Okay, so let me try in the last step to do the graph. The graph of both. Of course, I want to do quickly by hand. Okay, but I try to illustrate the idea in this book is super fantastic. I want to explain in detail. Any graph, guys, never by hand. Textbooks. And you make a copy, convert to picture, and attach to any test. But okay, let me try because it's my first time to do the graph by hand of the both functions. Okay, what functions? That function and that function. Okay, let's do it. Let's do it using point or let's do it using transformation. Oh, bueno, both. Suppose here in that side I want to do the evaluation of the x cubed plus 3. In this I do the evaluation on the inverse, que is cubic root x minus 3. So I suppose evaluate 0 because it's a nice point. It's over 3. Now the first point is the point 0,3. 1, 2, 3. Bang. 0,3. And why not? Another point maybe 1. 1 cubic plus 3. 1 cubic is 1 plus 3 is 4. It's 1,4. 1,4. 4 is one more here. Bang. It's a point 1,4. That's it. No, I don't like this because it's a curve. Because si it's a line, maybe 2 points is enough. But in a curve, 3 points at least. The negative 1 is good. Usually arbitrary, guys. The answer doesn't change. It's negative 1 cubic plus 3. And negative 1 cubic is negative 1. And negative 1 plus 3 is 2. So the point is negative 1, 2. Negative 1 is here, 2. Negative 1, 2. Okay. How are we connecting that? Well, it's a curve. And look like a parabola cubic. This is the graph of the x cubic plus 3. Everyone follow me? However, the beauty of this is that you don't need to plot this. No. Why not? Because you know the fact that the inverse x and y is interchange. So for example, that point gets 0,3 and the inverse would be 3,0. Yeah, I plot that. 1, 2, 3. Here, plot 3,0. Do you see? This corresponding with this. Another point, 1,4 would be in the inverse 4,1. 4,1. This is 4,1. 4,1. And negative 1,2 and the inverse would be 2, negative. 2, negative 1 is here. Negative 1, 2. Okay, now I connected this point. I'm connecting in one similar way to the cubic root expression. Entonces, look like, in my opinion, a little bit like that. This is the cubic root x minus 3. And make it sense, because if you analyze, no point by point, no, you analyze using transformation, the original is plus 3 outside, so it's a function plus 3, and this is the vertical shift, 3 unit up. Oh yes, makes sense. However, and the other, no, and the other is f of x minus 3. So this minus 3 is inside the parenthesis according to the function notation, because it's inside the radical, no? And the radical is considered like a grouping symbol. Therefore, this is no vertical shift. This is a horizontal shift 3 units to the right, because it's negative. Wow, fantastic. I like that. So the only difference between this curve and this curve is the same shape, but 3 units to the right. But the most important I want to indicate now, notice that these points are symmetric with the line, bam, 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 que represent y equal x, que is identity function. So that distance is exactly the same, that distance and exactly the same, symmetric. This behave like a mirror, that distance is equal to that distance. This is super easy to make a graph of the inverse if it's given the original or in both directions. No? It's given the original red one, and the only thing you should do is interchange x and y. That's it. Do you understand very well this example, guys? But let me show you now in Desmos. Let me show you now in Desmos. Where's Desmos? There you go. Okay, let me share the screen for the Desmos now. Okay. Switching to screen to Desmos. Do you see Desmos now? Yes or no? Do you see or no?
Yes.
Yes.
Yes. Look. This is, wow, what the hell? Look at that. This is the original, let me flash in. This is the x cubed plus 3. It's the cubic parabola, but 3 unit up, vertical shift. This is the identity function that I put in dotted line, que represent the symmetry, and this is the cubic root. Okay, I put like a 1/3. It's equivalent. Cubic root and raised to the cubic power is the same in green color. And you see the point are symmetric: 1,4, 4,1, 0,3, 3,0, negative 1,2. I select this point, but if you select another point, it's the same. It's the same. Everyone follow me? Who make a noise?
Yes,
I Werner. You make a noise?
Do you mind if I ask?
Say again?
Can I ask a quick question?
Go ahead.
It's on this. Like, since the homework and test 2 has been extended to the 15, is the written test also extended?
Yeah, I explained at the beginning. Okay, the reading test. Yeah, no, it's okay. The reading test is due today at midnight. You send me. So you have some problem, guys. Communication is important in the online class. When you take online class, communication with the professor is important. If you have some problem, some issue, you communicate, but not communicate now in front of everyone. Communicate with me private by email. But technically, today is the due date for the reading test. However, I extending a little bit the due date for the online because some students communicate and need more time to finish to this Wednesday. Okay, there's 15, no? March 15. That's it. This is the situation. You understand, Mister? I burn it.
Yeah, I understand.
Oh, cool.
Yeah, I understand. Sorry,
Okay,
it's-
cool. Let's continue. Let's continue. Do you see clear the graph in Desmos? Yes or no? Yes? Okay.
Yes.
Let's move on to the next second example. I want to erase my board. Example 2. Example 2 look like easy, but it's tricky. Example 2 is the function is given is the quadratic function, right? X squared. However, what is the step 1? What is the step 1? What is the step 1? The step 1 and the procedure is determine say 1 to 1 or no. What do you think about this? Let's say 1 to 1 or no?
Professor, we don't see your board.
Sorry. Sorry. Switching whiteboard. Now? Now?
Yes.
Okay, cool. Now the example 2 I say is the function is f of x equal x squared. My question was, this function is 1 to 1 or no? How you determine 1 to 1, see to be 1 to 1? What are the famous tools that we are using to determine say 1 to 1 or not? Come on, guys, say something. No idea. You pay attention or not?
Professor, what was the question again?
My question is, what is my first step in the analysis of the function?
Factor, right?
Why what?
Factor.
No. No. Switching the chapter. We are a new chapter. Is
Determine if it's 1 to 1.
exactly determine if the function is 1 to 1. So I repeat the question again. What do you think about that function? Is 1 to 1 or no?
No.
No, because it's a parabola, you know, when you apply the horizontal line test, fail. Yes or no? Let's see, this is giving the problem like that. You say, Professor, I cannot do any more in this problem. However, of course, I change something. I put semicolon. I put x greater than or equal to 0. And when I write that, some students say, well, what the hell is that? What the hell is that? This is the restriction. So now my function is not the full parabola. It's a half of parabola. Make sense? By the way, the positive part of the parabola. I can define that or in another branch, but I like in the positive part. So now under this new condition, this function is 1 to 1, yes or no? Is 1 to 1, yes or no?
Yes.
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 All right, everyone follow me or you are totally lost? Huh? Everyone follow me. Come on, any minimum question you have, let me know. It's important. See,
Professor, I'm kind of lost.
you can love. Okay, good. Okay, I explained at the beginning. Focus it, please. I explained at the beginning. Suppose I give you this problem like that. Yeah, I say determine inverse. What is the first thing you should do? Investigate si the function is 1 to 1 or no. Because I know very, very well that if the function is not 1 to 1, it's not invertible. So the inverse function do not exist. This is the first thing you should do. But the only tools that we have in my hand to verification this is the famous horizontal line test. Entonces, I know que this function, the graph look este parábola, ¿no? And when you apply the horizontal line test, fail because touch and 2 points. So far, you follow me? Mister?
Yes.
Yes. Mister? Is a woman say yes.
Yeah, I heard.
Okay, cool. But you understand, it's my question, no?
Yes, I understand.
Cool. Now, entonces, I need to fix it because if failed, this test this function is non-invertible and this is totally impossible compute inverse. Impossible. However, I fixed that. How we fixed that? I put semicolon. I put x greater than or equal to 0. So this new function under this restriction is different. It's only one branch of the parabola. Make sense? The positive part. Entonces, es important. So you need to understand the importance of this thing. Can look like nothing. No, it's changed completely the meaning of the problem. Now, when you apply the horizontal pass, because touch or cross it in only one point. Now it's 1-to-1, therefore the inverse function exists. Cool? Mister, everything okay? So some example, no?
Yeah, everything is good.
Yeah. Some example happen que you need to semicolon, and this semicolon indicate like a restriction, no? Actually, it's the domain. It's the domain. Okay, not bad. Now, yes, in that moment, I prove que 1-to-1. I want to do fast because it's the second example, no? Now I go directly to the second step, que es determine the inverse function. So I need to determine the equation for the inverse function. Okay, remember, you take the original, you replace f of x for y. Now this is the crucial moment. You interchange x and y. Guys, this is the most important idea today. X equal y squared. Because I have no idea that part. Don't try to write after I conclude something. And this is the inverse, but an implicit. To find the inverse explicit, you try to solve for y. You apply square root both sides, and square root x is equal y. And this new y is the inverse function. Let me enclose in the box this important idea. Inverse function is a square root. And this is totally logical. Get the inverse for the square function is a square root function. Okay, the inverse of this is this. You follow me? You follow me? Weird or clear?
Yeah,
Clear.
Clear. Now I need to check it. Remember, the step 3 is checking. To verify. How you verify? Well, you verify. Put together each other like a composition, F composition, F inverse, and F inverse composition F. You don't need to do both. Only one you are doing if you get the identity, the meaning of that is the function undoes each other, therefore they are inverse functions. Suppose que I'm doing in that direction. Entonces es like the inverse function is this. You plug it in here. Actually, we have replaced x for square root x squared. And these two and these two. And now square root and square cancel out each other. Bam! Identity function. Now, let's do it in opposite direction. Opposite direction is you take that and you replace inside here, plug it in here. Actually, we have square root x squared. Makes sense? You replace x for x squared. Same situation happens. Square root and square together is x. Cool. Verification. True. Undo each other. What about domain? Well, actually, domain of the f was this. It is bracket 0, infinity. No? Yes or no? And the range of f, no idea. But domain of the f inverse, yes, I have idea because I know very well the restriction when you have a square root. Okay, you take the expression inside the radical symbol and put it greater than or equal to 0. So this is exactly coincident with this. Is bracket 0, infinity. And the rest is easy. This is the range of the inverse. You know that this is equal to this. And this is equal to that. This is a theorem. It's a fact. In this example, it's a coincidence that 4 sets are the same, but not always happen. And number 5 is super easy because it's the square and the square root. Let me try to do my best here. The rule. All right, let me try. Here, 0. Horizontal line. This is the x-axis, and this is the y-axis. You know very well. The function y equal x squared. Of course, under the restriction x positive and 0. So the first point is 0, 0, 0. This point is 0, 0, because 0 squared is 0. No? Another important, interesting point is 1. 1 and 1, because 1 squared is 1, so it's 1, 1. And another point may be 2, this is 1, okay, 2 squared 4, so it's 2, 3, 4. And this point would be 2, 4. Okay, and you connecting, of course, no line, it's a parabola, like that, and this parabola increasing faster here. This is the famous x cubic, no, sorry, x squared, under the restriction semicolon, x is positive or 0. Okay, entonces, doing the graph of the inverse function, que es y equal square root x, semicolon, x greater than or equal to 0, que es that part is easy because you interchange x and y. 0, 0 stays the same. It's 0, 0. For the inverse and for the direct. 1, 1 is a coincident. 1, 1. 2, 4, no. Because you interchange to say 4, 2. 1, 3, 4, 2. This point is the point 4, 2. Because our graphic look like that. This is the graph of the square root x, semicolon, x greater than or equal to 0. But you see more clear in Desmos. You understand the idea? It's super easy, guys. Super easy. In my opinion, the complicated part is the second step, that part. But when you have that, everything flows quickly. Flow quickly. Okay, let me show you the nice graph in Desmos. Okay, let me share this screen. Switching to Desmos. Okay, do you see Desmos? Do you see or no?
Yes. Yeah.
Okay, let's move on to example 2. Here's the example. You see in the language of the Desmos, you indicate like that. Open curly bracket, external. This is domain to see only one part. Look. Bam, nice. Okay, look. Let me show you. This is in blue color, the parabola. Okay. In orange color, the square root function. In dotted line, black color, the identity function split perfectly the two functions. And we have typical points 0, 0, 1, 1, 2, 4, and 4. Bam! Super clear, in my opinion. Any question? What part is confusing? Come on, opinion. Are you clear? Everyone follow me? Yes or no?
Yes.
Oh, yes, I will have another extra example, a little bit more complicated. But you are strong in that part, so maybe you understand more clear. Do you see my whiteboard now? Do you see my whiteboard? Oh no, not yet?
Yes.
Yes.
No, not yet.
Not yet. Let me try again. Okay, sometimes happen get the internet connection and your computer is not fast. Oh, sometimes happen I try to do again. Okay, whiteboard, switching to window, open the whiteboard. Do you see now whiteboard? Answer me.
No.
Not yet.
Still on the
Not yet.
on the other
Okay.
page.
The other page. Wow.
The one with the decimals.
No, it's okay. It's okay. It's okay. Because sometimes I need to do something. I click like stop sharing, and now redo the start sharing the page. And sometimes work, sometimes no. What do you think? Tell me. Do you hear me well or no?
Yes.
Do you see my whiteboard or no?
Yes. We can see now your whiteboard.
Sometimes I need to stop sharing. And after, well, example 3, let's do example 3. You help me. Example 3. Look like a little bit complicated. Suppose the function f of x is equal 1 over x plus 1. In that case, we have rational function that we studied in the other chapter. It's not important now. Degree 0 and degree 1. Okay, but this is it's not important now. It's rational function. This is the given. And we are doing exactly the same. Remember the step. Step 1 is determine if 1 to 1 or no. Step 2 is find the inverse. Now step 3 is verify. Step 4 is determine domain and range of the 4 functions. 2 functions, sorry, not 4. 4 set for 2 functions. And finally, the graph. The graph is very complicated. And the only possibility for doing is using decimals. Okay? So now, I anticipate you, to don't confuse you, que this function is one-to-one. After that, I promise que you see clear in decimals. So in the real life, how do you know? Well, you typing in decimal the equation and you apply the horizontal line test. But I anticipate this because I don't want to switch into decimal. No? When I go to decimal to see what function, you see more clear. Okay, so I skip a little bit the step one. Step two is determine the original function. Entonces, what should I do? Well, you replace f of x for y. And you interchange x and y. And this is the complicated part. Pay attention, please. X equal 1 over y plus 1. The same version, yeah, but an implicit. I don't like implicit. So I need to do something algebra to isolate the y part. But it's easy. Let me show you. You apply cross multiply. So x times y plus 1 equal 1. Because 1 times 1 is 1. And just you apply distributive. Why not? And you move this x to the other side. Subtraction. And finally divide by x. And now my new y is this, is equal 1 minus x over x. And by the way, this new y is the inverse function. Do you follow me? Okay, this is my new equation que represents the inverse function of this problem. And this is my given beginning problem. Okay? Do you understand anything I do? Or no? Or I need extra explanation? Super clear? Es just sale, ¿verdad? Cross multiply and solve for y. So you apply your algebra, that you very well know, to isolate the y. When you have the y isolated, cool. This is the inverse function. Okay, verification now. Verify. Number 3, verify. Verify. How you verify? Well, you find the composition and give the order. If you get the identity function, fantastic. I am happy. So you don't, so you make a mistake for the middle. Let's do it in this order. Look, I take the inverse function. Okay, is this? Okay, I plug it in where? Here. You replace by x. So in my mind, I am doing that way. 1 over big box in the place of x plus 1, because now I'm plugging in 1 minus x over x. Do you understand the thing I am doing?
Yeah.
Cool. Now I copy. I copy one more time. Well, no, I don't copy. I just delete the box. Yeah, I try to do my best in algebra to simplification this. Okay, 1 and 1. So in the bottom, I condensing these two fractions in one common denominator, que by the way is x. X divided by x is 1, multiplied by 1 minus x is 1 minus x, plus something, x divided by invisible 1, we have here is x times 1 is x. Do you follow me? So basically, the only thing I'm doing is, you have two fractions with different denominator. I condensing in only one fraction, finding LCD and the corresponding numerator, no? Entonces I saw something clear. Wow, look at that. This positive x and negative x is cancelled. 1 over x. Wow, reciprocal or reciprocal. Flip it out. It's a 1 over 1 times x over 1, flip it that, the answer is x. Cool?
Yes.
One time que you are doing this is enough. However, I am a teacher, no? I want to illustrate the verify in two directions, no? Entonces now suppose que I am doing in opposite direction. Opposite direction, and you take this as substitution, but it's more complicated because you substitution here and here. So you, in other words, you replace x in the inverse function for this entire expression. Entonces, I suppose que I organize in that way. 1 minus box divided by box. And inside the box, I copy 1 over x plus 1. 1 over x plus 1. Do you follow me? Do you understand very well this idea? Que es confusing, I know, I understand. Do you understand?
Yes. Yeah.
Okay, now, the only thing I should do is manipulate the numerator part, que es two different things with different denominator, but the LCD is obvious que es x plus 1. X plus 1 times 1 is x plus 1 minus 1. This one and that one. And the top and the bottom, no, I don't touch for a moment. Now, you see clear that this positive one and negative one I cancel. And stay x over x plus 1 divided by 1 over x plus 1, division of the complex fraction. You copy the first exactly the same, multiplication now and flip it the second. Wow, that part is canceled and stay only x over 1, because use x. Verification. Well, normally one direction is easier than the other. So not necessarily do it in both directions. Okay, this is number 3, get verify. Verify if my inverse that we found is good or not. It's obvious that when you put together each other, the action for the inverse undoes. Okay, now domain and range. This is the most important part I want to practice with you now. Domain. Domain of the original. Range of the original. No, I put here range of the original. Domain of the inverse. In this order, doesn't matter the order, but I need to domain of the inverse and range of the inverse. Okay. To find the domain of the original is easy. Easy, because look. You take the original, that one. It's a rational function. Yeah, I know very well. Okay, you take the denominator expression, that one. X plus 1, no 0. Therefore, x is no negative 1. The domain is all real number except negative 1. Negative 1 is a bad guy. It to be undefined my original function. So say, well, you can express in interval notation or no. Let me try to save time expression in this notation gets easier when it's only 1 point, x such that x no negative 1. Everyone follow me so far? Yes or no? And this range will be the same. But the only difference is you express it in self-builder notation, que es a range, entonces y value, such that y no negative 1. You see it's the same thing. The only difference is this is domain is x and this is range. Okay, let's move on to the inverse. Remember, it's Relatively easy, determine the domain. We have practice. And the range is always complicated. No good. And you see que the denominator es x only, x no zero. Entonces es x such that in the inverse function x no zero. Now this is equal to this, que es y such that y no zero. Boom, I finish. So far, everyone following? Yes or no? Come on, guys.
Yes. Yes.
Cool. Now, the graphic part, I want to see because it's complicated a little bit. It's a rational function. To do it by hand it's hard for me. Okay, so now let's do it using decimal. But I want you notice one important idea. I suppose you remember very well vertical asymptote and horizontal asymptote and the rational functions. But in this case, we have both vertical asymptote and horizontal asymptote. But you know that the inverse interchange x and y. Therefore, interchange vertical asymptote and horizontal asymptote. Let's see clear now. This is the most important moment, at least for me. Look, decimals. Switching to decimals. Let me know if you see or not. You see decimals?
Yes. Yes.
Cool. Example 3. Here's the last one that we discussed. Okay, look. Oh, too complicated. This looks like complicated. It's crazy. Okay, let me focus in the original guess giving at the beginning. Okay. This point no good. And this point is good. Not the orange, you know, the green. Okay, I have my original function. Look at the function y equal 1 over x plus 1 is given at the beginning. Okay, look. Now I determine that we have one vertical asymptote, a negative one, bang, and one horizontal and y0, bang. It's logical. It's logical. However, I have the famous identity function. Bang. I need to know the graph of the inverse function is symmetric, is like you reflecting the red curve around to the axis of symmetry, no? That's the line y equals x. Let me try to do my best. This is, let me make it zoom, look. Let me make it zoom. You see the symmetry or no? Okay, to have more clear idea, let me complete some point. Suppose this point, okay, 1/2, 1. Let me make a label. You see and the original is 1,5, and it's a 0.5, 1. And the inverse function is -2, -1, and the direct and the inverse function would be -1, 1. However, also the new horizontal asymptote is at y equal -1, boom. And the vertical asymptote is at x equals 0. So it's confusing because we have too many lines. So I want to delete, or not delete, put on enable the vertical and the horizontal of the original. And why no? I delete and this I focus in the purple color, get the inverse function. Do you see how? The most important I want to see, one of the symmetry of the bone you see before. But the new thing I want to illustrate is how the number and the vertical asymptote and the original is switching to the horizontal asymptote and the inverse function. And likewise, in the horizontal y equals 0, que es the horizontal of the original, look, it's changing to the -1, que is exactly the same value. And do you see, guys, or it's confusing? Okay, let me try to do it. Restore that one. Bam. In red color, the original. In blue color, in purple color, the inverse function. And you see it's the same thing. Ah, yeah, one thing I forgot to explain. For example, the original is 1-to-1 or no? What do you think? Let me erase everything. Bam. Bam. This is the original. It's 1-to-1. Of course, it's 1-to-1. When you apply the horizontal line test, pass. Okay, cool. I understand very well, or no?
Yeah.
Let's come back to the whiteboard. You let me know si I'm doing well or no. Do you see my whiteboard?
Yeah.
Cool. And you, miss?
Yes, I see it too.
What is your name? Jamie?
Leslie.
Wow, you are very dedicated. And you always have to investigate what is the due date, professor. That you are very strict with the class. I feel.
Yeah, I work a lot, so I don't want to go behind.
Exactly. Never behind. Always 1 or 2 steps forward. Okay, so now we start, and the time we have not too much, start study exponential function. Exponential function, guys, que es a little bit contra-intuitive function, because the majority of the people don't imagine how fast increasing that function. Maybe you hear that phrase, the exponential of our planet increasing exponential. This is not true. And you understand in your moment why. Not necessarily now. However, the population of the coronavirus, yes, increasing exponential. And the reason, intuitive reason que es exponential is, si one population increasing exponential is because we have enough of food, for example, bacteria, virus, a small animal like a rabbit, mouse, increasing faster because not exactly exponential, but approximately exponential. Virus, yes, and bacteria, yes. Because suppose that this colony of bacteria have in one habit that have enough of food for them. And we have enough space, no limitation, no problema. However, the human being, no. The human being living in one planet, the population increasing, and one idea that is impossible increasing exponential is because in between human beings we have contradiction, we have word, and the bacteria don't fight in between them. No, it's no problem. I have my food. I am a little bit stupid. No problem. I have food. I have space. No problem. I increasing exponential, and the human being, no. After I want to explain more in detail this idea. Okay, so let's go to the mathematical part. Definition of the exponential. Definition is one function is exponential. See, look like that equation, a to the x. And who is a, professor? A is the base. Okay, it's important that you understand. Suppose in the parabola we have x squared. Everyone understand very well. However, if I want to convert to exponential, this is 2 to the x. Look at the difference. The exponent is 2, and the independent variable Sx. Here is different. The independent variable is in the exponent part. That is a reason that this exponential increasing faster than this. This is increasing faster, but this is increasing too fast. And important to understand very well the exponential is the base. The base is the number that you have here, that by the way is any real number. Be careful, except, it's important, the exception. Always positive, no negative, so a negative 2 to the x is impossible. Exponential, this is impossible, definitely no. The base illegal, totally illegal to be negative. And the reason you can see in detail next time. And also no 1 and no 0. This is not impossible, but it's stupid, it's trivial, because 1 is a magic number. When you raise to the any power, it's always 1. It's a trivial, totally trivial. Likewise, 0 happens similar situation. However, you see, bueno, professor, entonces, what is the range of the variation of the base? I want to explain it now. Look, suppose this line represents all real number. All real number. And this is positive infinity and negative infinity. However, I know by definition, suppose that this is 0, okay, we have only exponential in the positive part, not in the negative part. However, we have two important intervals. You see that no 0, no 1. So we have one kind of exponential in which the base lies in this. This is when the a is in between 0 and 1, not including 0 and not including 1. And we have another kind of exponential starting 1 to infinity. And this exponential is when it's greater than 1. And what is the most important characteristic? This exponential in red color is decreasing. And you see now in detail, decreasing. Entonces somehow in the majority of the science subject que using exponential, when it's decreasing, call it decay. And the reason it's decay is because the population decreases. It's going down. Now, in this case, no. It's completely opposite. This is increasing. And this is growth population. This is synonym, no? You know, sometimes you can see increasing or growth, or sometimes you see decreasing or decay. This idea is clear. Entonces now, well, suppose a couple of examples. Suppose we have one exponential like that, one exponential like that. This is 3 over 2 raised to the x, and this is 2 over 3 raised to the x. What do you think about this exponential? Is increasing or decreasing? All right, the first one. What do you think? Increasing? Increasing, very well. And the second?
Decreasing.
What, you can explain me the reason?
Well, the first one, it's a value higher than 1, and the second is a value lower than 1.
Absolutely, yeah. As you see, you analyze the base, and the base is 3/2, get 1.5. 1.5 is bigger than 1, it's increasing. And it says 0.6 repeated, is less than 1, is decreasing. This is the idea. Very, very well. So now I spend the rest of the time, que este minute only, to analyze at least one example of the exponential. The basic, the Easter. the elementary. Now, example one of the exponential, we take advantage to study and detail its property. Suppose the exponential f of x equal 2 to the x. Wow. What do you think? Is increasing or decreasing?
Increasing.
Increasing, because the base is 2 and 2 is greater than 1. Cool. So we expect. Okay, now to understand, I want to create one table. In the table, I put different value of the x. I want to plot this in a tricky way using table, and y equal to the x. Here the point x comma y. Yeah, I put arbitrary. No arbitrary. I put 0. I put 1. I put 2. It's okay. You put -1 and -2. Be careful, guys. Pay attention. Now the first one is y equal 2 to the 0 power, and you need to know very well that any number or expression raised to the 0 power is equal 1. Entonces es the point 0,1. Wow, wow. Entonces, profesor, 0,1 is always one point that belongs to the exponential. Yes. So it's universal point. Universal point. Because regardless si the base is 2, si es 3, si es 1/2, si es 1/3, any number, doesn't matter, right? Raised to the 0 power is 1. This is universal. When you try to do the graph of the exponential, don't forget the point 0,1. It's a universal. Let's continue. Positive 1, easy. 2 to the 1 is obvious que es 2. And the point is 1,2. 2 is y equal 2 to the second power, que es 4. And the point is 2,4. Everyone follow me?
Yes.
Okay, now let's see the negative guy, que es confusing. Y equal 2 to the -1. Uy, uy, uy. 2 to the -1. Remember, negative exponent means reciprocal. Do you remember this or no? Flip it up.
Yeah.
Excellent.
Yeah.
One
But you're
half.
gonna plot it like that on the graph?
Yes, after you see in detail. Let me finish the table and immediately I go to the graph. So the graph is -1,2, no? And y equal 2 to the -2 is 2 to the -2 is reciprocal 1/2 to the second power positive, but flip that and it's a 1/4, 1/4. It's a 1/4. And the point would be -2,1/4. Do you follow me?
Yeah.
Excellent. Okay, now I go to Desmos. In Desmos, I see more clear, more elegant my graph. Okay, let me try. This is another Desmos. Let me try to find the Desmos I prepared for you about that part. Exponential logarithmic. Cool. Okay, let me share the screen. I suppose it's the last thing I tried to see today. Okay. Do you see my Desmos or not yet?
Yeah.
Okay. Example 1 is y equal 2 to the x. Wow, it's expecting, it's increasing. Of course, remember the idea decreasing or increasing. Remember, when you want to determine if one function is increasing or decreasing, you walking from left to right, and you go like a roller coaster on the curve. See the car of the roller coaster goes up, it's increasing, no? Entonces, important. I plot the point exactly like the table. The first point was 0,1, 1,2, 2,4. I plot more, and then 3,8, because 2 to the third power is 8, and 2 to the fourth power is 4, comma, so 2 to the 4 power is 16, and so on, 32, 64, blah, 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 blah. It's increasing too fast, by the way. However, in the opposite direction, si I plug in one, -1 is 1/2, it's 0.5 in decimal. -2 is 0.25, is 1/4. We did this in the table and stop here. However, si I continue, -3 is 1/8, que is 0.125, and 2 to the -4 is 1/16, que is 0.063. Important. You see that the function is increasing, passing through always for the famous point 0.1, and also important, have always one horizontal asymptote at y equals 0. Look at that. This is my famous horizontal asymptote. Because the point, the y value, approached to 0, but never touch. So what is the conclusion? What is the most important property in the exponential? I come back. But let me try to analyze. What do you think about domain and range of the exponential function? So let me try to look in the graph. Let me switch into the whiteboard to copy the property. Look. No. Whiteboard. Do you see whiteboard again or no?
Yes.
Good. Okay, now look. Erase. What is the most important property? The property at least of that function. After we generalize. But no. Number 1, domain is all real number. No restriction. Exponential function is nice function. Accept any value, positive, negative, 0. Okay. However, domain range, no. Because you see that never is only positive. The answer that the exponential function offer is always positive. And never 0, because asymptotically. Entonces es 0, infinity. Never negative and no 0. Number 3 property, the function is increasing. Yes or no? And the reason it's increasing is because the base is 2. We study next class when the base is another number and the behavior change. The base is 2. And 2 is greater than 1. By the way, that function is neither no symmetric, no odd, no odd, no even, it's neither. Remember, even, odd, neither. This is even. Maybe, right? This is odd. And another way is neither. Our famous exponential is like that. That means that the positive part and the negative part, you need to plot completely separately, independent. Entonces now, for example, we have also important horizontal asymptote. Any exponential has horizontal asymptote at y0. Of course, this is the basic. You see, when you have transformation, maybe change or no. And 6 is the typical point to plot any exponential graphic. Is the universal point 0,1, 1,2, because in this case the base is 2, 1,2, and negative 1,5. Okay, it's that point. Look, negative 1/2 and 1,2. In general, no. Suppose another exponential that the base is no 2. You have the universal point. This is universal always. and the graph is 1, A, and the base is A. In this case, it's a coincidence que A is 2. And negative 1 is reciprocal, 1 over A. Suppose, well, suppose nothing, the time is over. How was the thing today, guys? You follow me or not?
Yeah.
Okay, cool. And now we finish. Bye-bye. Have a nice day. Remember, today send me the written test. Okay? Bye-bye.
Okay, thank you, Professor.
Mhm.
Okay, thank you, Professor.